when we balance equations, it's important that we obey the law of conservation of mass. Remember that says that you cannot destroy nor create matter. So any matter you have at the beginning of a reaction on the reactant side must be present at the end of the reaction on the product side. So let's consider the combustion of ethane. Okay, ethane is C2H6 and it's a gas. When it burns, we need to remember to add oxygen gas as our reactant because we need oxygen to burn. And because we're burning a hydrocarbon, something that contains hydrogen and carbon, we will make two products, and those are carbon dioxide and water vapor, also a gas. Because remember, that's a hot flame, right? So your water's going to be a gas. Okay, so that's what I call a skeletal equation. It's just a bare bones equation. We've got reactants on the left and products on the right. And to see if it's balanced, we need to count how many atoms of each element we have on the left-hand side and the right-hand side. So go ahead and write those element symbols underneath the arrow. We just have 3 elements in this reaction: carbon, hydrogen, and oxygen. And you count how many atoms of each element you have on the left-hand side and how many atoms of each element you have on the right-hand side. So we've got 2 carbons on the left, 1 carbon on the right, 6 hydrogens on the left, 2 hydrogens on the right, 2 oxygens on the left, 1, 2, 3 oxygens on the right. Okay? So, clearly, the equation is not balanced. To be balanced, these numbers must be equal to these numbers. And as you can see, they're not. So that tells us our equation is not balanced. Now, the only way you can balance an equation is by balancing the atoms. And we do that by writing coefficients in front of the formulas. We cannot balance an equation by changing subscripts or by adding or subtracting things to make it balanced. The only thing we can do is write coefficients in front of those formulas. So for example, we've got 2 carbons on this side. So to balance carbon on this side, I can write a number 2 there, and that gives me 2 carbons. It also changes the number of oxygens though, because this 2 means 2 carbon dioxides, so it means 2 carbons and 4 oxygens. 2 times 2 is 4. So we've got 4 oxygens plus 1, 5 oxygens. Okay, now let's balance hydrogen. We've got 6 on this side, so if I put a 3 here, 3 times 2 is 6, that will give me 6 hydrogens on that side. That also changed our oxygens. 2 times 2 is 4, plus 3 is 7 oxygens. Okay, now I left oxygen to last, and that's because it's on its own. If something is on its own on one side of the equation, balance it last. And the reason we do that is we can put any number in front of this oxygen and it will balance the oxygen and we'll be done. We won't have to go back and change anything else because oxygen's on its own here. So carbon is balanced, hydrogen is balanced, oxygen is not. I have 2 oxygens on this side and 7 on this side. So I need to make 7 oxygens out of an O2 molecule. Now remember, an O2 molecule contains 2 oxygens, right? So to get 7 oxygen atoms, I'm going to need an odd number of oxygen molecules. And our coefficients do have to be whole numbers at the end, but it's okay to have a fraction as an intermediate step. And the easiest way to work out what fraction you need is to say, okay, I need 7 oxygens, and my subscript on my oxygen is 2. So I need 7 over 2 oxygens. 7 over 2 is the same as 3.5, so you could write 3.5 if you prefer. 3.5 times 2 is 7. So that balances our atoms. We now have an equal number of atoms on each side. So that's a balanced equation, but I've got a fraction, and my coefficients, these numbers in front of the formulas, have to be whole numbers. They also need to be the lowest whole number ratio. So to get rid of a half, I need to multiply by 2. If I multiply this by 2, I need to multiply everything else by 2 to keep it balanced, right? So no coefficient means 1, right? The 1 is always implied. So if I'm multiplying 1 by 2, I will get 2. And then I multiply 3.5 by 2, I get 7. 2 by 2, I get 4. 3 by 2, I get 6. So my coefficients are 2, 7, 4, and 6. And those are the lowest whole number ratio of coefficients that will balance this equation. I've got 2 times 2, 4 carbons. On this side, 4 carbons. 2 times 6, 12 hydrogens. 6 times 2, 12 hydrogens. 7 times 2, 14 oxygens. 4 times 2 is 8 plus 6, 14 oxygens. So now my equation is balanced.